Hello everyone, it's December 29th. Alright, we've got an easy one today, so very simple. We're gonna get this one done and we're gonna implement the other faster algorithm, and let's do another easy one, you know? Yeah, I know. What is this? Oh, yeah, we can try this one as well. Damn, mark some queries. I don't quite remember how I do this. I remember some type of sorting for this one. Yeah, some type of sorting. I remember my way, but I don't remember the official way. Oh, I remember. My way is no, I'm not doing my way. Lord, my way is segment tree. Nah, we're not doing segment tree. We're not. Ah, I don't remember. Don't remember this one either. I remember this one. All right. It's okay. It's okay. All right, just I get this one done first. Redistribute characters to make all strings equal. You give an array of strings, 0 index, and one operation, pick two distinct indices, I and j, where words I is a non-empty string, and move any characters from words I to any position in words j. Hold a second, what are we doing? We pick two indices, okay, where words I is a non-empty string, and move any character from words I to any position in words j. Return true if you can make every string in words equal using any number of operations. So basically we move something from one word to another word. And then we can do it however many times. So basically all we need to do is to check if there are, like, let's say words, this list has length n. So we just need to check if each letter is a multiple of n. That's it. So the first one is true because we have 3b, 3a, and 3c. Second one is false. Okay, we can just go right into it. Lordy, I need to make this one bigger. Or we just made this one a bit smaller. Okay, what are we talking about? What are we talking about? This is what we're talking about. All right. What do we do? So first thing we're gonna get a no. We don't do a counter. We do this. Okay, new int 26. That's that. And then we're just gonna go through everything. So for string word of words. All right. Oh no. Get back. And we can say for char c of word dot to char array. All right, and we're gonna say counter c minus a. Okay, plus. Blah blah blah. When we're done, and we have to go through everything. We say for int c, however, char c have int c of counter if c mod words dot length is not equal to 0, we'll return false. Otherwise, we'll return true. Okay. No. What are you doing? 0. Try it. It should be right. 1897. Make sure the count of each letter in all words is divisible by the length of words. on, where n is the total number of letters in words. That shall be it. I don't know why it's so slow. Maybe there's some trick. Today is 4:30. I don't know. Do we have a trick or whatever? Count frequency. Python is a one-liner. Counters. Oh yeah, that was smart. Yeah. Count with array. ONK. It's the same thing. Oh, this is what we have. This is my way. Wait, hold a second. What is this? Oh, you use it. It's the same thing. It could be medium. Yeah, here we go. Medium. All right, so that's that. All right, let's implement the faster way. So again, the idea is DP, right? And what we're gonna do is for each new day, we create, or like we say for each new subarray, we create a, well, how should I just say it? A DP array, a 1D DP array, in which DPI represents the minimal difficulty, ending at I, and with the given number. Yeah, let's write it out. This one is done, so we can close this. I'm pretty sure the other thing is right here. What is this? Oh no, I did it in, I did it in Java. Okay, let's just do it in Java then. It's not my intention. All right, so let me so this is the faster solution. I checked my previous from 2 years ago, from more than a year ago, it is still DP, in which DP I J represents the minimum, the min difficulty, ending at job difficulty J with I number of subarrays. However, we can do this using a 1D DP and 2 DP arrays, one for the current call it temp, and the other for the previous, for the current I, for the previous I. Oh, it's not previous I, for I minus 1, right? We can call it dp. The real trick to make this solution OND is that we use a monotonic decreasing stack, right, to speed up the check from j back to 0. From don't say from j back to 0. From job difficulty j back to job difficulty j to 0. Notice that any values between some job difficulty k to job difficulty j, if all the values between are smaller or equal to job difficulty j, then as we go from j to k, the difficulty of the subarray does not change and remains job difficulty j. Therefore, if we use a monotonic decreasing array for all the job difficulty, on the left, we only need to compare with very few, right, of them, since all the other job difficulties would be smaller than the ones in the stack, right? And we can pop, right? We can pop. Once we encounter some job difficulty, k that is bigger than job difficulty j, the current difficulty would be the same as the difficulty of the previous, okay, of the previous. Of the previous dpk. No, it's actually temp k. Of the previous difficulty already computed for job difficulty k. Then we continue with the stack. Yeah, with this setup, each value in the job difficulty array is visited at most twice. Hence, the overall complexity is O and D. All right, let's implement it. So first things first, we need a let's go back here. We need a DP array, right? We need a DP array for previous, and we need for the current. The first one shall be D shall be from 1, right? So the first one, and each one wait, do we restart the stack every single time? I think so. We start the stack. Hold on.
Please. Oh shit.
Alright, I'm back. I think I do have to do the stack every single time, unfortunately. Alright, the start of this is always the most difficult. So at the start, we're gonna create, right? And then what? You start, and you will go back. Right, for each one, what's DP0? DP0 initially is going to be it's just by itself, right? It's just by itself. And if it's by itself, the first one is just going to be, shouldn't that be the sum? Yeah, it should be the sum, right? Hold a second. So, oof. All right. I'm not sure. Let's just try it. So from I equal to 1, okay, I smaller equal to d, I plus plus. This is outside, right? And each time, I think we need a stack every single time. So I need a stack. Right, what stack? We say list integer. We call it stack. Oh, I think I can do a stack itself. Stack, right? st. Okay, call stack. New stack. Oh yeah, I can do that. All right, so we have a stack, and we need an int, which is lordy. I'll call it temp. New int. Shouldn't that be job difficulty dot length? And then I think every value should be set to, because we want to find a minimum, right? So we probably should say for I0, I smaller than job difficulty. Let's call int n is job difficulty dot length, and we can call n, and here we can do n. Okay, and then I plus plus. This one is just to set every single thing to integer dot max value. Oh, I can do fill. Nice. Okay, so now we filled it with max value, and then, right, and then what should we do? Well, we should go with j, right? J shall start with a certain position, right? Shall start with a certain position, because I is 1, so j has to be starting from 0. If I is 2, j must start. I is 2 means we have to have 2, so we have to start with here, right? So I say for int j shall equal to I minus 1, j smaller than n, j plus plus. Okay. Okay, so this is j. So for each one, right? For each one, for each j, we need to fill. We need to fill. It's gonna be job difficulty j, right? And if it's a value, then we need to check into the stack, and now we can stack in a pen or put it in. But for the first one, because when we first start, there's no stack, right? But we need to set the temp value. When do we set the temp value? Well, the temp value is set along the way, right? Along the way. So, yeah. So what we do is while because we're gonna check, right? We're looking at J, and we're gonna check. So we say while stack is empty, right? Basically we say while stack is not empty, and stack dot peak, right? Stack dot peak. We put index in it. So stack dot peak job difficulty. Oh, hold a second. So job difficulty, right? Stack dot peak. If that is smaller or equal to job difficulty J, right? If that is the case, if that is the case, then we'll do stack dot pop, right? Because this one is not useful. But when we pop it, right? When we pop this, we need to update temp. Right? We need to update temp. How do we update temp? Now we say we update temp by, because we pop this one out and this one is smaller, right? So basically everything up to this, so I probably need to give it a name. Let's say int k is equal to this. Okay, so this index gets popped and it will be combined into the current subarray, right? Therefore, if it's combined into the current subarray, then temp j shall equal to math.minimum temp j, and so we need a dp as the previous, right, ending at k minus 1. I'm pretty sure it should be k minus 1. Previous ending, because we are popping at k, right? We pop at k, so the previous one is, so k is not so k, I'm including k into the current ones. Okay, I'm including k into the current ones, and once I include k into the current one, so everything in between is smaller, right? So we include k into the current ones. Therefore it shall be dpk minus job difficulty k, right? dpk is the previous, right, minus job difficulty k. That is wait, is that dpk or is that temp k? Because I want to know, because yes, it's a dpk, because dpk is where the previous number of subarrays ending at k, right? But what I want to know is the previous subarray not including k, right? Not including k. What is the smallest? What is the value? So shouldn't that just be, dpk minus 1? right? dpk minus 1 is not including k, which is the same as dpk that is up until k, right? That is up until k. But I can do dpk minus job difficulty k, or minus that, and plus job difficulty j. It's like, now if I'm trying to do 3, then I need to know the job difficulty of 2. Now I think it should be k minus 1. Seriously, I think it should be k minus 1. Hold on, I think k minus 1 makes more sense to me. K minus 1 makes more sense to me. And a plus job difficulty j. That's what makes sense to me. Right? That makes more sense to me. And then, yeah, we just blah, blah, blah. We keep going, keep going. And at the end, we say, regardless, stack dot push j. Right? We're going to push j into the stack. We're going to push j into the stack because at the end, yeah, regardless, we push j into the stack. But hold a second. If stack dot is empty, if we still have something in the stack, then we have yet another way to get temp, right? Because temp will be including, so we say temp j shall equal to math.minimum temp j and temp stack dot peak, because at the end the job difficulty j meets someone that's bigger than it, and we say we're just gonna group everybody into it, right? Once we group everybody into it, it's just gonna be temp, yeah. And at the end, stack dot push j, and we are done, I think. Right? This is the whole thing. We're done. And once we're done, we say dp equal to temp. Then we start a new round. Okay. So what about the first, when I is equal to 1? Now when I is equal to 1, j starts from 0, right? Stack is empty, and I don't have temp j, right? I'm not putting temp j. So I probably should say if j is equal to 0, temp that's not really true, right? How do I, because j will start, so like the first one, right? The first one, and the stack will always be empty, right? The stack will always be empty. Yeah, how do I settle in the first value? Smallest, I think I need to do temp, right? I think, hold on. I think the temp, we need to say for int j equal to 0, j smaller than I minus 1. Well, we can say j smaller than I, j plus plus, right? So all of this under the current. Nah, those are impossible case. Those are impossible case. right? Those are impossible case. Oh yeah, it's impossible case. It's like we have more subarrays than what's possible, right? So those are impossible, 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 and the first one, right? The first one is the first one that is possible, right? If let's say I is equal to 3, and then j, the first j, 3 means we have to have 3 subarrays. So j start with 2, right? J start with 2, and that value is going to be the sum of everybody, right? Going to be the sum of everybody. So what we need to do is to how shall we say this? How shall we get the first value in? Lordy, lordy, and lordy. And stack or pop. And what if k is this is bonkers, man. This is bonkers. It just means you haven't fully understood. Because I don't remember seeing this part yesterday when we checked the answer. Let me think again. Yeah. Yeah, so we're talking about the first one, right? And if it's just 1, yeah, the first one we need to set. The minimum job difficulty is the sum of, right? Therefore, the minimum job difficulty ending at here is just the sum of everything, right? And then we'll try this. We'll try the next one. So we try the next one. And what is on the stack now? Okay, so we put everybody on the stack. We put everybody on the stack. That doesn't feel right, man. That doesn't feel right. Does not feel right, because like I have to pre-create the stack. And why do I pre-create the stack while I'm creating the stack? Right? So J should be going from 0 to n. Hold on. J should be doing this, right? And then basically we just say this is fine. And then we'll push, so we say J from 0, right? And And we can say here, if j is smaller than I minus 1, no, if j is larger equal to I minus 1, then okay, so we say if j is larger equal to, because if j is smaller, we don't make any changes. It should be impossible until we have the first, right? Until we have the first. And but what about the first j? Well, we produce something. We produce some stack, and then stack is not empty, and it depends on whether we can. I think we need to at least do the first DP. Yeah, I don't know. I feel wrong. This feels wrong. Let me see. DP temp. Okay, we have to stack every single time. What is K? K in range D. From K to N. Temp I equals dpi minus 1 plus I guess I'm almost there. All right, this I shall put it. I forgot about this. So this is the schedule difficulty on 0th day. And temp starts with 0. Temp starts with 0. Look at this. What is this? Everyone will set temp I equal to dpi minus 1 plus job difficulty I. I agree. So this is the starting point. And then we do the rest. Holy crap. Okay, so, oh my goodness. So this is not right. Okay, I do create stack every single time. Yes, the stack is recreated every single time, so that one is correct. But the so this is fine. So I think this is still I minus 1, right? Yeah. That's the first one we can start. And that is the first one we start. And hold on. So what we learn is we get dp is new int n. and we say we'll fill it. So we'll fill dp with this, and we'll say int, wait, cannot resolve fill, oh shoot, my bad. So it'll be this, and int, this one will be temp. This new int. Right, that makes sense. We don't need this, we don't need this. Okay, let me do this one more time. So I starting from 1. This is a good comment I had on the other solution. This is represents, right? Represents the result of zeroth, or of having 0 subarray. If you have 0 subarray, everything is impossible. Okay, and then temp is this. This is a good. So we're starting from here. So this is the key. So this is where everything starts. Oh, this challenge is about doing one problem every day. That's it. Straightforward, simple. And of course, you try to do more than one. And sometimes I got stuck like this. Old problem, just keep getting stuck. So this is where everything starts. We need to say the temp, right? This is where everything starts. So we say temp j, right, shall equal to something, right? What is this something? Now j is starting from the first possible position, right? The first possible position. And it shall be essentially dp. Oh, thank you for the wish. It shall be dpj minus 1, right? It's because the previous, this plus job difficulty j. Okay, so this is where everything starts, and this is the minimum possible j position to allow I number of subarrays. Okay, but of course this might not be possible, so we have to check. Say if j is, if it's equal to 0, then we do 0, otherwise we can do this. Okay, good. So this is where we start, and then we will do all the stack thing. Okay, so the stack, so this is fine, we don't have to do this, and then this is, I guess, fine, right? Will k be 0? I don't think k will be 0, because I'm pushing j, and when j starts with 0, stack is empty. So I will push, no, I will push j equal to 0 though. Then how do I prevent? I think it's the same problem, right? If k is equal to 0, that means we don't have a dp. What does it mean when k equal to 0? So I pop everything, right? I pop everything. And if I pop everything, then the job difficulty for the current one, if I pop everything, so the current job basically has the smallest. No, not the smallest, it's the biggest. The current is the biggest, and it should take the current, which means this I do have to check. K is equal to 0. If k is equal to 0, that will be 0. Otherwise, it will be this. Okay? So this now makes sense. And then at the end, we check this. This will make sense. Right? Right? And then we'll push. And then We'll set dp equals temp, and I need to swap them. No, I don't want to swap them. Come on. All right, let's not swap them. Who are we kidding? Right? Who are we kidding? Let's just do this. So we create a new temp every single time. Okay, so blah 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 blah. Once we done everything, and at the end, what do we return? We return the last because dp is equal to temp. So at the end, we want the last index. So we shall return dp.length -1. We say, oh, I don't need dp.length. This is just n, right? We say this is equal to integer.max value. If it is, we'll return -1. Otherwise, we'll return dp n -1. All right, one more thing that we can check it. If n is smaller than d, right? If that's the case, return -1. Okay. Oh, my God. Man, I'm telling you, if I have to do this like in a month, I'm not able to. I am not able to write this one again. For one thing, I'm not even sure this is correct. Nope. I think. Oh God. Oh. Well, how do I transition to programming to constant? Well, just do more. There's really very little to say. You see more problems, and then you kind of get a feeling, right? And I mean, LeetCode have something that helps you is it tells you the constraints. This is usually my trick. You see the constraints and kind of can guess what type of complexity is going to be. Like for this one, the length is 300. It's very small. So in your mind, like, okay, O(n) squared, right? Something O(n) squared will be allowed. So when you start trying to get into the problem, and then it's like it looks like a DP problem, right? It's a tough one. So most of the time, a tough problem is a DP problem. So you say, okay, so it's gonna be a DP problem, and I can allow me O(n) squared, and then you see the D, right? It's another one, another input. So basically the input, we have the length of this and this. So you can figure, okay, O(n) squared, maybe you can also times D, right? Oh, okay, so O(n) squared times D. So this kind of give you an idea what the DP gonna look like, all right? So you say, okay, for DP, I might have to go through everything here. I go through everything here. That's O(n) times D. And then during each subproblem, because I have another n to spare, so maybe I can go through this one more time. So yeah, just from this, you start to build up the algorithm. And of course, what I'm trying to do right now, I'm trying to do O(n) times D instead of O(n) squared times D. Because yesterday, we did this, which is O(n) squared times D. And it's pretty straightforward, O(n) squared times D. But it's slow, right? It's very slow. It's only 7%. So I know there's a better solution. This is what I done a year and 2 months ago. It's O(n) times D. And what I'm trying to do now is to recreate that problem, that solution back then. But I'm having just so difficult to get to it. I don't know. I think the max value is also tripping me. Okay, so I'm not gonna do this max value. What I'm gonna do is create a max value. I think that's what I did yesterday. We're gonna create just int max, right? The max value I think is 300,001. 300,001. Okay, so instead of doing this, we're gonna do max, because that will definitely not overflow. Okay, so we're gonna try this, and see if it works. Ah, come on. Come on, let's work. Come on, let's work. Lordy, still not working. Oh, all right. So what went wrong? So most likely somewhere here, because that's what I make the change. No, not this one. I think this one's fine. It's probably this one. Because we start, right? Every time when we start, it's going to be, okay, I think this is right. And then as we go through, we check the stack, right? And then if the peak is smaller, I'll pop it. And then I will do this. And then I need to check if k equals 0, if k is 0 is this. I don't know. It looks... Dude, it looks fine. It looks fine to me. Ah. Alright, just line by line. Okay, this is fine, this is fine. I have an infinite, that's fine, that's fine. I have a stack. Okay, everything's good so far. And it's okay, because for me, I starts from 1 to D, and my basically J here starts from this. It's fine, okay? I think so far so good. And this my temp is equal to this plus this. This is fine. And while stack, and this is fine. I will pop it. This will equal to minimum. This. Okay, this is where I differ, right? This is where I differ, but I really don't think that was the issue though. Because it makes sense to me, right? And if stack, I'll do, this is fine. I'll do this. I'll do this. Dude, everything looks fine. Oh Lord. Okay, so let me change this then. Okay, let me change this then. This is something I don't understand from yesterday, so that's why I don't want to do it this way. Okay, so basically for me, it's gonna be temp k, right? What's temp k? Temp k is at k position, given the current number of subarrays, and temp k minus job difficulty k, right? This is basically what we say. For here, minus job difficulty k. When we do this, we're saying the current number of subarrays ending at k, okay? Then I minus k, which means I'm minus... Okay, it makes sense. It makes sense. The current subarray, let's say 4 subarrays ending at k, and I minus job difficulty k, that means I remove a subarray. Okay, I remove a subarray that is ending at k. Right? I remove a subarray ending at k. I guess it's fine, right? A subarray ending at, not really remove a subarray ending at k. It's just I remove this value. So k, job difficulty k, basically does not exist, right? If it does not exist, then temp, yeah, I guess it makes sense. I guess it makes sense. I don't like it, but let me give it a shot. Let me give it a shot. So which line? This line, right? So I'll give this a shot. Come on. No. Okay? It's the same result. So that's not the issue. Oof. Okay, that is not the issue. I'm gonna go back to my old way. I like the old way. Then what the hell? What the hell? Everything else is the same. Card. Okay. DP is max. That's fine. Temp. I recreate temp every single time. I think that's fine. I recreate a stack. I go this. Is this where it's wrong? I say I larger than 0. If I is equal to 0, same thing, right? If j is, because I need to do dp, so I is j, okay? I is j. So I say j is equal to 0. If j is equal to 0, I do 0. Otherwise, I do dp j minus 1 plus job difficulty j. That doesn't seem to be wrong. And then everything just, it flows. It's right. Damn it. Okay, so we have to debug. I have no clue. I have no clue whatsoever why this one is wrong. It looks so good to me. Alright, so this is int. What's this one? Int job difficulty. Okay, new. Let's say int. Okay, I need another one. I need int d equal to 2. Okay, so we're gonna do this min difficulty, job difficulty, and d. All right, I will put let's put it here. All right, debug. All right, job difficulty, dp, that's fine. What is this? This is step into, no, step over F8. Okay, go F8, stack, that's fine. This is fine. So j start with 0. Okay, temp j shall equal to job difficulty j, which is 6. Okay, temp j. No. Oh, I think I know why. Oh, Lord. Parentheses. That is why. Yes. Oh. It's the parentheses. I like this DP. I like this way. Okay, so yeah, now we can submit. No. No. Oh gosh. Okay, so I cannot do it this way then, right? Okay, let's try the other one, which is I remember it's temp k minus job difficulty k. I'm in a sulking. So I have to use this. Why? Why the DP doesn't work? I mean, what we are doing is we say job difficulty k is going to be grouped, right, into the current. So once I group it into the current, temp k is up into k with, the current I number of subarrays, okay, the current I number of subarrays, ending in k, what is the smallest thing, okay, and I minus job difficulty k. What this means is I remove and I plus, but what I want is the previous. What I want is the previous ending at k minus 1. That's what I want, right? Ending at k minus 1. Why is this not right? What I want, because the current stack, it's a small value, right? It's a small value, and previously, okay, we're ending at this, and I say I have to pop it. And I can do temp k, which is the sum. Remember, temp k is going to be the sum of, let's say we have 4 subarrays, okay? We have 4 subarrays, and then temp k is the sum of the 4 subarrays ending at k, right? The minimum value that we can get. And if I minus job difficulty k, that means we're removing the subarray that, it just doesn't make sense, okay? So temp k minus job difficulty k, that does not make sense to me. That does not make sense to me. But if I do job difficulty, that also does not make sense because it's wrong. Eight. Yeah, 8 doesn't right. 8 is not right. Temp k minus job difficulty k. What did I say about saying which is job difficulty? This might reduce the counting once we reach. Now, I didn't really talk about why we do this. Group all jobs from J to I together. But why we do this? I don't know, man. I don't know. Why we do this? All the jobs that have difficulties lower than job I, the facilitator we use yes. If the tail of the stack is smaller than job I, then we can group that job with job I. So we pop it from stack and update. But still didn't say why. Still didn't say why. Minus this plus this. Because we have a new, right? A new subarray is from, in this case, alright, we have this subarray because we want to include this value. We want to include a k, right? We want to include a k because k is smaller. So the whole thing will have job difficulty I. Okay. Now the question is, what is the minimum of the previous? Which I say is going to be dp k minus 1. Ending at this. Ending at ending at K. So I take this one, right? So we say the minimum of this minus job difficulty K. That doesn't make sense. That does not make any sense. Okay, let's debug this. That's the only way. That's the only way for me to figure out why, you know, my idea doesn't work. Okay, let's put. All right. F8. Okay, first is 7. Okay, stack is 0. Can I see stack? Second, J is 1. Oh, shoot. Let me do this. Okay. So the second one, J is equal to 1, right? And I can do F7 dpj minus 1 is 3 is max. How? That doesn't make sense. Yeah, so we have the first one and the second one. DP starts with all. Then every single one is going to be the maximum. Everyone's going to be maximum, okay? F7, F8. Because now temp J job difficulty is 1, right? Because job difficulty is 1. So temp J shall equal to the previous one can cover it, right? So yes, now becomes 7, 7. Go up. Should still be 7, 7, 7. Temp is 7, 7. What's temp? 7, 7, 0. What? What the hell? Hold on. That doesn't make any sense. First 7. Okay, so let's just Okay, here. That's good. Now it's 7. Right? Oh! Man, after this, you better remember to put the parentheses. Two instances of parentheses. Alright, but the debugger is good, right? Because I saw it like, wait, what, 0? What the hell? 0? What the hell is 0 doing here? Yeah. Come on, this should be right. Yes! 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 Oh. Okay, come on. That's the last one. Oh. What the hell? What the hell? Shoot. I thought that was the reason why. I mean, it's not working, huh? It's not working. So this dpk-1 idea is still not right. But that's the only one that makes sense to me, man. That's the only one that makes sense. That temp thing doesn't make sense. Because we're popping k, right? We're popping k, and we need to basically everything up into k. We need to create, yeah, dpk-1. dp is the previous number of subarrays, right? So we say the previous number of subarrays and a k-1, right? Ending at k-1 because k. Oh, wait, hold a second. Well, right now it's just k, right? Just k, because k is smaller and will include k. That's why we say k-1. I don't understand. I don't understand. I think I'm gonna end today for now. So I need to think like why this one doesn't work. I need to think about it. All right, I'll end it right now. I'll see you guys tomorrow. Adios.